Okay, so today we're going to talk about properties. We're going to identify and use properties of addition and multiplication. We're going to use properties to simplify algebraic expressions. So, when you make a peanut butter and jelly sandwich, do you spread the peanut butter first or the jelly? The order does not matter because in the end you have a tasty sandwich. Okay? So it doesn't matter whether you do the jelly or the peanut butter, it still goes together. Doesn't matter. Okay? And that's what we're going to be kind of talking about properties. So let's talk about the properties of addition and multiplication. In algebra, properties are statements that are true for any numbers. For example, the expression 30 plus 10 and 10 plus 30 have the same value of 40. This illustrates the commutative property of addition. Likewise, 30 times 10 and 10 times 30 have the same value, 300. This illustrates the commutative property of multiplication. So this is just when you change the order of things. To evaluate the expression 16 plus the sum of 14 and 58, use mental math by grouping the numbers as the sum of 16 and 14 plus 58. Since 4 plus 6 is 10, this illustrates the associative property of addition. There is also an associative property of multiplication. So this is when we change the grouping. You notice in this one, we group the 14 and the 58 together. In this one, we group the 16 and 14 together. And in this problem, the reason that they did that was it's a little easier to add 16 and 14 and then take that answer and add it to 58. So just to make things a little easier, you can use the associative property of addition or multiplication. All right. So in addition to the commutative and associative properties, there are other properties that are also true for any numbers. So we have the additive identity. And this is when 0 is added to any number, the sum or the answer is the number. So for example, 5 plus 0 equals 5, or 0 plus 5 equals 5. So any number added to 0 will be that number. The multiplicative identity is when any number is multiplied by 1. The product is the number. So for example, 8 times 1 is still 8, or 1 times 8 is still 8. So any number multiplied by 1 is the number, or the answer is the original number. And then we have the multiplicative property of 0, and that states when any number is multiplied by 0, the product is 0. An example of that is 3 times 0 is 0, or 0 times 3 is 0. Any number times 0 is 0. Do these properties apply to subtraction or division? One way to find out is to look for a counterexample. A counterexample is an example that shows a conjecture is not true. Okay, so we're trying to figure out something, whether it's true or not true. And if it's not true, we need to supply a counterexample. So for example, in subtraction of whole numbers, is subtraction of whole numbers associative? If not, give a counterexample. So can we have subtraction with associative property? Let's take a look. We'll just throw some numbers out there. 9 minus 4, or the difference of 9 and 4 minus 2. Is that the same as saying 9 minus the difference of 4 and 2? So let's take a look. If we did our parentheses, we have 5 minus 2, which would be 3. We have the parentheses, 4 minus 2 is 2, so 9 minus 2 is 7. So they do not equal. So this is a counterexample. So subtraction of whole numbers is not associative. Okay? So to answer that problem, I would have to supply a counterexample and then state that it is not associative. Okay? So name the property shown in the statement. So we are to name the property. We have 15 times b, which equals b times 15. The order of the numbers and variables changed. So this is the commutative property of multiplication. All right. So we can take a look and let's do an example. This is where I want you to pause the video, Try to answer this on your own. Is division of whole numbers associative? If not, give a counterexample. So try this on your own and then come back to the video and see how you did. All right, so let's see how you actually did, okay? So is division of whole numbers associative? Let's take a look. So the associative property is when we are changing the grouping. So let's take a look. Let's say we have 27 divided by 9 divided by 3. Does that equal 27 divided by 9 divided by 3? So we didn't change the order, we just changed the grouping. So that would be associative property. So let's see if that works. So if we do 27 divided by 9, we would have 3 divided by 3. And on the other side, we would have 27 divided by 9 divided by 3 is 3. 3 divided by 3 is 1, and 27 divided by 3 is 9. So therefore, that does not equal. So we could say that division of whole numbers is not associative. Okay, so that's how I would answer that one. All right, good job. All right, now go ahead and pause and try 2A, 2B, 2C, and 2D, and let's see how you did. Okay, so on these, I want you to just identify the property. Okay, so what type of property is used in these four? Okay, all right, pause the video. All right, let's see how you did. 2A, it was D plus 0 equals D. That would be the identity property of addition, or you could, or the additive sorry, I was trying to see if I wanted to abbreviate it. Additive of identity. Okay, 2B, we have 8 times 1 equals 8. So 8 times 1 equals 8 would be the multiplicative identity. Okay, and so you could just simply put like that. Then on 2C, you have 14 plus the sum of 9 and 10, and then we regrouped it to the sum of 14 and 9 plus 10. When you regroup, you're using the associative property of addition. So we can actually simplify that as, let's see, how did I abbreviate that? Let's see, associative. Yeah, I did not abbreviate that at all, did I? Associative. Let's do this. Let's just add an addition sign. That'll work. All right. And then on 2D, we have, we didn't change a grouping, but we changed the order. So that would be the commutative property of multiplication. So we would put let's just do that, okay, to make it a little bit easier. So that's how I would identify those four. All right. So simplify algebraic expressions. To simplify an algebraic expression, perform all possible operations. You can use properties you learned in this lesson. Using facts, properties, or rules to reach valid conclusions is called deductive reasoning. So let's take a look. So it says to simplify each expression. We have 9, the sum of 9 and r plus 7. So what we could do is we could first rearrange and use the commutative property by putting the sum of r and 9 plus 7. Then we could use the associative property and regroup. And so we're changing the grouping. Now we can add 9 plus 7, and our final simplified would be r plus 16. Okay? Let's look at B. So on B, we could use the commutative property of multiplication by just changing the order. Then we could use the associative property of multiplication by changing the grouping. So instead of grouping the 5 and the x together, we're grouping the 3 and the 5 together. And then we're multiplying the 3 and the 5 to give me 15x, okay? Now remember, when you do these, the only way that you can change the order or change the grouping is if all of the operations are the same. So in this one, they're all multiplication. In the one above it, they were all addition. So that's important to keep in mind, okay? Let's see. So it says, which of the following is an example of commutative property of addition, okay? Remember that commutative property of addition is just where you are changing the order, right? So we take a look at this, and we know that D would be eliminated straight off the bat because this is the identity property of 0. Anything added to 0 is that number. And then we can eliminate B because B is the associative property of addition because we're changing the grouping. Here we are grouping 7 plus 8, and here we're grouping 8 plus 2. So we know it's not a grouping, we're just moving numbers around. Option C can be eliminated because it's multiplication, and we're looking for the commutative property of addition. So that leaves us with A. And if you look, all we're doing is changing where the plus 5. In this one, it's plus 5 at the end. In this one, it's 5 plus at the beginning. So A would be the answer. Okay? That's deductive reasoning. Now, pause the video and try these last two. Now, when you try these two, that's where you are simplifying, but you need to identify every step that you use. So just like when we did the examples and we listed out what parts or what property that we use for each step, you need to list that out as well, okay? So pause it, see what you do, and then come back and see how you did. All right, so let's see how you did. So on 3A, what we could do is we could regroup. So we could group 12 times 10 times z. And if we did that, we are using the associative property of multiplication. Okay? And then simply we just have to 12 times 10 is 120 times z. Let's do that so we know it's a z. All right? And that's just, we could just write down simplify. Or we could also put multiply 12 times 10. Okay? All right. Let's look at 3b. So the first thing we want to do in 3b is we want to rearrange. We want to go 10 plus 18 plus p. Okay? And if we rearrange that, we'll just call this step 1. And step 1 will equal the commutative property of addition. Okay? Then what we would do is we could regroup. And we group 10 plus 18 plus p. And that would be step 2. And step 2 would be the associative property of addition. And then step 3 would be simply to solve 28 plus p, which is simply simplify. And that's it. And that's how you do it. Okay? That's today's lesson. If you have any questions, just let me know. Have a great one.